everyone, welcome to our video on finding the area between two curves. Now, to find the area between two curves, we just have a picture here to kind of describe it. So between F and G is this green area. That's what we'll try to find. And the way that it breaks down is just kind of using geometry tools to help us. So the area under F is in this second portion. So it goes from the curve all the way to the x-axis. And then in the pink here is the area under G. So if we take the green area and take away the pink area, that would leave us with this initial green area from the first picture. So that's all we have to do to find these. And one of the ways to think of it, okay, so the area between curves is kind of nice versus like thinking about net area versus just regular area. It's always like this. So area between curves, let's put it right here, area between curves is equal to, so we'll use kind of the integral notation, so from a to b, so wherever they're telling us where to start, of our top function, so whatever's higher, minus the integral from a to b of the bottom function. Or you say like the higher function over the lower function, or minus, the lower function. So like in this problem, the f is the top function, G is the bottom. Now, it doesn't matter what F and G are. Maybe they change those letters. It's still whatever is the top one minus the bottom one. Okay, and that's all you have to worry about. You just set it up like that, and then you're ready to go. Sometimes A and B are not given, and we'll find those by setting equations equal to each other. But we'll see that in a different video. So let's go with this here, where what we typically like to do is, well, one thing to remember is these x equals are vertical lines. So remember, x equals a number. That's a vertical line. Whereas y equals a number, that would be a horizontal line. Let's put the word line in there too. Okay, so with this problem right here, so what we want to do in these problems is always sketch it. So step one is let's go ahead and make a quick sketch. Okay, so we'll have our sketch, and with this we have x equals -3, so I'm going to say that's something like that. And then x equals 2, so maybe something like that. And then y equals 1 is something like this. There we go. And then y equals x squared plus 2 would be, so this is a parabola, and if needed, we could always go to Desmos as well. So I'm going to just type that in, or use whatever graphing calculator you like. Okay, so here's Desmos, and let me go to the graphing. Let's also make it so you can see it all. Okay, so here's the Desmos, and we could always sketch it in. If you know what that one looked like right away too, then that's good. It's going to be a parabola. Okay, so there's that. But you could also do all the others. X equals -3, x equals 2, and then y equaled 1 was all of it. Okay, so this might be useful for us on here as well, and then we can kind of see what they want. So it's the area between all of these curves. So it's going to be this region right here. We'll draw it on our picture and we'll shade it in. Okay, so we've got something like this where there's a parabola. So my scale's going to be lost at this point, but I have a parabola, something like that. And so what they want us to find is this shaded area. Okay, what's nice about these problems, well, looking at this, so, and they use just y, so notice it's not f of x and g of x, but this is definitely the top function, which is that x squared plus 2. This, y equals is still f of x, so remember y equals f of x is function notation, so this is a function, y equals 1, so this would be the bottom function. The bottom equals, let me just say y equals 1 instead of, so I'm just saying the top function, let's abbreviate top func, and our bottom func is just 1. So we have x squared plus 2 is the top function, and 1 is the bottom function. And it's really y equals those. Okay, and what's really nice about these is where it starts, these ones are given. So usually if they give you just these x values, that means the bounds are given. So here was our x equals -3, and here's x equals 2. So this is really the a equals the -3 in our integral, and this would be the b equals 2. So it's whatever the smallest one is to the biggest one. Okay, so that means our setup for this, so our area between these curves, I'm just going to write area, is equal to our integral from -3 to 2 of our top function, the x squared plus 2, and then we just attach dx to say we know we're going to do it with respect to x, like that. And then you can put a big bracket 2 minus, or it's up to you if you want that big bracket. Actually, let's do it like this for now. So minus, and let's do another integral, still from -3 to 2, of the bottom function, which is just 1, and then dx. Okay, so this is showing them separately. Because they are the same integral from -3 to 2, we could just combine it and say it's x squared plus 2 minus the second function like that, and then dx. So this might be easier in the long run, but I did want to show it in this one with our first top one. So I was doing it like this top one minus the bottom one. But then again, it's usually better to just put it all together at the end. Okay, and then now, well, let's simplify. So this is our integral from -3 to 2. And then we have x squared. +2 minus 1 would be just plus 1. And then now let's just do this integral. No big deal. Okay, so if we do this integral, we would have x cubed over 3 plus x. And then we have our bounds, -3 and 2. And then I'm going to do the 2 in blue. Okay, so if we plug 2 in, we're going to run a little low. Let's put it to the side. So if I plug 2 in, I'd have 2 cubed over 3 plus 2 goes into that x, so plus 2. And then like always, it's always minus -3 getting cubed over 3. And then plus a -3. We'll just write it like that. There we go. And then now let's just simplify. Okay, so this is equal to, so I'm going to put it way over here to make sure we fit it. Okay, so 2 cubed is 8. So we have 8/3 plus 2 parentheses minus, this in the red, -3 cubed is -27. Divided by 3 would be -9. And then plus a -3 would really be just -3 like that. And so however way, and you could use a calculator too at any point, but at this point I would simplify the parentheses here. So we have 8/3 plus 2 minus -12. And then while minus and -12 would become positive, I am going to go ahead and combine 2 with +12 to make that 14. So we have 8/3 plus 14. And then at this point, just to get a common denominator, we would have 8/3 plus what is this? So 40, 15, 30, 42 thirds. And then we can finally add it to get 50 thirds. Okay, so that's how we could do it. So this is if they give us polynomials. So the top function is a polynomial. The bottom function is also a polynomial. It's just a constant one. Okay, but that's it. So the area between curves, again, I think it takes a little less effort than some of the other area problems. All right, but let's find out. Let's do one other here in this video. So let's find the area between the curves. Again, these are polynomials, and so it might be best just to sketch it right away. I'm going to use the Desmos calculator. Okay, so let me exit those, and we'll plug those in. We have x equals -2. We have x equals 1. We have y equals 5 minus 0.5x squared. And then we have y equals 2x minus 1. Enter. Okay, and so I want to find everything that's between all of those. Okay, so, and it could be, let me put it in the projector mode so we can see everything. Okay, so we've got the black line, blue, red, green. Okay, so in between the two vertical lines is where I'm first looking. So in between the black and the red. And then we see, oh, this little blue part and then this little green part. That's the area that they want. Okay, so first in between the two vertical, and then from the higher function minus the lower function. Okay, so let's set that up. So let's draw our picture so we can see it, and I'll shade it. So we have our, and it doesn't have to be perfect. Okay, so we had our vertical line, we had another vertical line, and then we had our line like that, and then we had our parabola all on this. Okay, so let's get our parabola in here so it looks something like that. Okay, and it's a little tough with all this ink going on here in the same color, but again, in between the vertical lines and then below the top function and above the bottom function is where I'm shading. So it looks something like that. And let me show this one more time. So it's not perfect, obviously, my picture, but it is below the blue curve, above the green, and in between the black and red is what I'm trying to draw. Okay, so with that, we do know what our x values are to start. So x equals -2. Again, that's really the a value that's in our integral. And this b equals 1, or x equals 1, sorry, x equals 1. That's really the b, though, is the 1. And then we could kind of see what the function is that's top. So it looks like our parabola is the top function. So we have top equals 5 minus 0.5x squared. And then we have our bottom function. Let's highlight it in the pink. Ooh, let's try that one more time, huh? Oh, no. All right, let's fix that. That was a good line. Okay, let's try pink again. There. Okay, so we can see the pink is the bottom one in this case. And so let's label that. So the bottom equals 2x minus 1. Okay, and so let's set up our integral where we're thinking, all right, so our area is equal to our integral from where it begins, -2, where it begins on the x coordinate, so -2, to where it ends on our x, which is 1. And then we'll take our top function, and we'll just put it in parentheses, so 5 minus 0.5x squared. So that was the top. And then minus the bottom function, also in parentheses, 2x minus 1. Bottom. Okay, so make sure those are in parentheses when you do the subtraction. And then we'll just throw dx at the end of it all to let us know that it's like a normal integral with respect to x. Okay, and then now usually it takes one step to simplify. So from -2 to 1. And then let's distribute that negative. So we'll have 5 minus 0.5x squared. And then minus 2x plus 1. And then the dx is attached. And then, well, it looks like I can combine one term. And let's go ahead. I'll put it in descending order as well. So from -2 to 1, -0.5x squared minus 2x. And then 5 plus 1 is 6, so plus 6. Okay, so that was just simplifying. And then now we can do the antiderivative. Let's put it over here because it looks like, again, rooms is an issue. Okay, so now I'm doing the antiderivative. So we'll go to -0.5x cubed divided by 3. So that's the power rule on the first one. And then we'll have minus, it will be just x squared. The antiderivative of -2x is -x squared. I mean, you can always do a quick check with the derivative. These are working. And then the antiderivative of 6 is 6x. And then we've got our parentheses and then a vertical bar, -2, 1. Okay, and then now, like always, I'm just going to plug in the blue one first up top as my color is 1 is going into these x's. And then we'll always minus the second one. Okay, so let's finish the blue one. So I'm going to put it right below, and then we'll use our calculator. So -0.5 over 3 times 1 cubed minus 1 squared plus 6 times 1, all in parentheses, and then always minus the second one. So -0.5 over 3 times -2 cubed minus -2 getting squared plus 6 times -2. All like that. Okay, and then this is where I'm going to use a calculator at this point, especially since I'm running low on room. So I usually prefer to use just the Desmos scientific one. Let me go ahead and make it bigger real quick so I can get... There we go. Okay, so now I'm on the scientific one, and I'm just going to plug this exactly in as it's shown in blue. Okay, so we have negative 0.5 divided by 3, and then in parentheses 1 cubed, and then minus parentheses 1 squared, and then plus 6 parentheses 1, and then parentheses. Okay, so I type that in identical, and then just double check, and then we can see that answer. I'm going to press enter just to see it, and then let's make it a fraction. So 29/6 is the blue portion. Okay, and let's come back in a second. And again, this is why I like this type of calculator. I'm going to highlight it and copy and paste because it's the same expression. It's just change the 1 to -2. So -2, -2, -2. And then we'll press enter on that, and let's go ahead and change that to a fraction. Okay, so we can see everything in the blue was 29/6. Everything in the red was -44/3. Okay, let me move that for a second. We'll copy it. Okay, so we've got in the blue was the 29/6. And then minus, it was -44/3. And then now I just need to do this. And you could change it minus a negative. Be careful. That would become a positive. So it is 29/6 plus 44/3. And then even here, you could still use the calculator to finish it off. Let me just go ahead and do that. So all I'm doing is 29/6. 29 divided by 6 plus 44 divided by 3. Enter. And then one more time, 39/2. So they usually like fractions. Okay, so 39/2 is that area. And that's it. We got it. Okay, so that's it. So on these problems, you got our strategy. Find the picture, and then top minus bottom in the form of an integral. Okay, so that's it. Let's put a pause. We'll do this E1 in a different video. But that's it for now. Thanks for watching, and I'll see you again.